Welcome back to the Explainer. So today we're jumping right back into jacking systems. This is part 2, and we're looking at RPD, fixation, and maybe the most important part, discipline. Let's get right into it. We're picking up exactly where we left off, exploring the seriously hidden dangers of lifting thousands of tons of solid steel. Think about it. How do you protect a massive oil rig from literally tearing its own legs apart? The stakes here are just astronomical. We're talking about elevating a colossal, multi-million-dollar structure, one that houses over 100 people high above crashing waves. Now, the big, obvious macroscopic forces are easy to see: gravity, wind, waves. But the real danger during the lift? Well, it actually comes from microscopic internal forces at play deep within the lifting mechanism itself. To really wrap our heads around this, just look at the sheer scale of the machine we're dealing with. This is the Ascapot. It's a Gusto MSC J70 Cat J rig, and it is an absolute titan. But here's the crazy part. This immense structure, weighing many thousands of tons, climbs out of the water using nothing but small electric pinion gears, turning against a toothed steel rack on each leg. It's an absolute masterpiece of mechanical engineering. But with all that weight relying on localized gear teeth, man, things can go wrong very quickly if they aren't perfectly coordinated. Let's do a super quick recap of how this rig actually climbs before we get to the one parameter that saves it from total destruction. As we saw in part 1, the rig uses independent variable speed drives, or VSDs, for every single pinion gear. This setup allows the control system to constantly monitor and auto-adjust the speed of each motor. It's in there making dozens of tiny micro-adjustments every single minute just to keep the massive hull perfectly level as it jacks up, automatically compensating for uneven seabed conditions or weird load distributions. Okay, now here is where things get really critical. We need to talk about RPD, which stands for rack phase difference. By definition, RPD is just the difference in vertical position between adjacent rack and pinion units on the exact same leg or between the legs themselves. Think about it like this. If just one single pinion gear climbs even slightly faster than its neighbors on the same leg, it starts pulling ahead. And when that happens, it exerts a massive, uneven twisting force on the steel rack. And let me tell you, that's a twisting force the rack simply was not designed to handle. And what you're seeing here brilliantly illustrates the solution to that twisting problem. Notice the complexity of these massive gear houses. Buried deep within these systems are things called RPD encoders. These encoders are constantly measuring the exact vertical position of every single cord on the leg. If they detect the absolute slightest mismatch, literally the tiniest rack phase difference, they instantly feed that data back to the VSD control system to automatically correct the motor speeds in real time. They are specifically designed to stop structural damage before it even gets a chance to start. So the crucial takeaway here is this: excess RPD isn't just some minor technical glitch that you can ignore. It is actually one of the leading causes of leg structural damage on jackup rigs worldwide. When those gears get out of phase, the sheer incredible tonnage of the rig, combined with the torque of the motors, will literally warp, twist, and just break the steel lattice of the legs. So RPD monitoring is quite literally leg damage prevention. Let's bring this down to a more familiar analogy so we can see how this works in real-world operations. Picture a house lifting crew raising a foundation on multiple hydraulic jacks, one at each corner. If one jack goes up even a fraction faster than the others, what happens? The rigid wooden frame of the house twists, groans, and eventually cracks. Professional crews have to watch every single jack constantly to stay perfectly in sync. Well, that's exactly the job the RPD encoders and the VSD control system are doing on the rig. It's the exact same principle, just scaled way, way up to a massive industrial level where a cracked frame means compromising thousands of tons of offshore infrastructure. No pressure, right? So let's put you in the hot seat for a second. Imagine you're the jacking system operator sitting right there in the control room. You're mid-jacking operation, lifting this colossal rig out of the water, and suddenly an RPD alarm flashes red for one of the legs. What is your very first move? What do you actually do? Well, the answer comes down to absolute ironclad human discipline. Step 1, stop. You stop the jacking sequence immediately. Step 2, investigate. And step 3, only once the issue is completely resolved do you continue safely. An RPD alarm is a hard stop. It is never, ever a suggestion. As a company man or a rig operator, you must never override the system or try to push through the alarm just hoping it'll self-correct. The technology is there to warn you, but strict human discipline, that is the ultimate safety mechanism. Okay, moving on. Let's look at what happens once the rig successfully reaches its final drilling elevation. because you really don't want the rig hanging entirely on those lifting gears for months on end. So the rig utilizes a leg fixation system. These heavy-duty counter racks actually physically engage into the rack of the leg. Once they're engaged, they lock in place with this massive mechanical click, locking the leg completely, 100% rigid against the hull. The entire philosophy behind this is captured in one very simple rule. Leg fixation means the load is taken completely off the jacking units. The counteract system is this purpose-built, super high-strength locking mechanism. By engaging it, you entirely transfer the immense structural weight of the hull, the derrick, and all those relentless environmental loads from wind and waves right away from the vulnerable pinions and gears of the jacking system and safely transfer it directly into the hull itself. And I cannot stress enough how profoundly important this single step is for the lifespan of the rig. By taking the load off the gears, you drastically reduce the fatigue and wear on the jacking units during a drilling campaign that might last for, many months. It means the lifting system is completely preserved, resting safely while the rigid fixation system takes the absolute beating from the harsh offshore environment. It's exactly this combination, RPD monitoring on the way up and rigid leg fixation once elevated, that keeps a rig's legs alive and safe for literally decades of service. So there we have it. The rig is up, it's locked, and it is completely rigid. It's ready to go to work. But to actually do that work, a jackup rig basically operates like a floating power plant. It's usually out there burning through massive amounts of diesel every single day just to power its drilling motors and keeping the lights on in the accommodations. But what happens when a rig designed for the absolute harshest environments on Earth decides to turn its diesel engines entirely off? Well, that brings us to a really groundbreaking green power upgrade on the Askapot rig. And that is exactly what we are going to be decoding in our next explainer. Until then, keep questioning how things work.